Hello dear students and welcome to the amazing platform of Technogate. Today we will discuss Ecet paper of Telangana State of the year 2023. Well, we will discuss the chemistry section. Here there are 25 questions. Each question carries 1 mark and all the questions are compulsory. We will discuss all the questions one by one. Okay, so let's start. Okay, here is our question number 1. Now, the values of azimuthal and principal quantum numbers respectively for an electron that is present in 4d orbital. Here we need to tell the azimuthal quantum number and the principal quantum number for an electron which is present in 4d orbital. Now, this value represents what? The principal quantum number, okay, the highest value or the shell number. Okay, so n would be 4. And now for azimuthal quantum number, we know that values of L for different orbitals for S, P, D and F. The value of L is 0, 1, 2 and 3. Right. So here our electron is present in d orbital. So the value of azimuthal quantum number would be 2. So now first they asked us azimuthal quantum number. So 2. And then principal quantum number, so that would be 4. So the correct option would be 2 and 4. That is option number 3. Okay, understood? It is very easy, basic question of atomic structure. Okay, next question. Okay, what is the question? Which of the following molecule has ionic bonding? Okay, from all the options. First of all, let's see all the options. Here CH3Cl, CH3OH, CO2 and MgO. So in which of the following ionic bonding is there? So let's see. The structure of CH3Cl is like this. See? And there is no ionic bond. Okay, these are all are covalent bonds. So covalent bonding is present in this case. Then the other option is CH3OH. Again, it's like this. Here also no ionic bond. It is also covalent bond. Okay. Our next option is what? CO2. CO2 molecule. The structure of CO2 molecule is like this. Okay, so here also covalent bonds are present. And our last option is MgO, that is magnesium oxide. Now this molecule is formed when magnesium ion loses 2 electrons and form Mg+2 ion. Okay, and the oxygen atom gains 2 electrons and form O2- ion. Okay, and then there is an ionic bond. Electrostatic forces of attractions are present between Mg+2 and O-2, and the octets of both the atoms are complete, fulfilled. So this is the ionic bond is present in which molecule? MgO. Clear? Okay. Let's take next question. Okay. What is the oxidation number of carbon in formaldehyde? Okay, what is formaldehyde? So formaldehyde is HCHO. This is formaldehyde, HCHO, and its structure is like this. Now let's consider its oxidation state of carbon is X. Now X plus oxidation state of hydrogen atom is +1. Then again oxidation state of another hydrogen atom is +1. Then oxidation state of oxygen atom is -2. And as there is no charge on this molecule, so this all will be equals to 0. Okay. From here, when we would solve it, our value would come out to be 0. So the correct answer is 0. The oxidation state of carbon in formaldehyde molecule is what? 0. So our correct option would be option number 3, 0. Clear? Very easy. Again, basic question. Okay? Now, next question. Okay. Now, the molarity of a solution containing 9 gram of glucose in 500 grams of water is. Now here we need to find out the molarity of a solution. We know very well the formula for the molarity of the solution. What is it? Molarity is equals to number of moles of solute upon volume of solution in liters. Okay, this. Now we are neither given number of moles nor volume of the solution, but very easy to find out. Let's see how. Now number of moles is what? Of solute is what? Mass upon molar mass. So we are given both the things. Now the mass is 9 gram of glucose. Okay. Then molar mass is 180. Okay, so we will put 180. This is our number of moles. Now about volume of solution. Now we are not given the volume of solution, but we know that density is equals to mass upon volume. From here volume is equals to mass upon density. Okay, volume is equals to mass upon density. From here the mass is given to us as 500 gram and density of water is 1 gram per ml. Okay, you need to remember this. This is very easy, and sometimes in questions it would be mentioned, and if not mentioned then you should know that density of water is 1 gram per ml. Okay, as we are putting this value in gram and per ml, so here we will need to make conversion. What would we do? Here multiply by 1000. Okay, as we are taking this value in ml. Now we will put our value over here, 500 upon 1. Now we will solve it. As you will solve it, you will get the molarity as 0.1 molar. Okay, just by solving it we will get the answer 0.1 molar. So our correct option is option number 2. Clear? Very simple. Every time just remember the formula of molarity, the basic formula. This is very important. Okay, the basic formula, that is molarity is equals to number of moles of solute upon volume of solution in liters. Okay, if it is in milliliter, then we need to multiply by 1000 in the numerator. Now number of moles is of solute, mass of solute, molecular mass of solute. Then volume is density is equals to mass upon volume. So volume is equals to mass upon density. Mass is given and density is 1. So just we put all the values in the question and we get our answer. Okay, clear? Okay. Next question. Prussian blue colloid is. So that is this. Potassium, iron in 3 oxidation. Its name is potassium here. Iron, its oxidation is state over here. Over here it is +3, and then hexacyano, because there are 6 CN molecules, 6 CN, so hexacyano ferrate. Here the oxidation state of iron is 2. So this is Prussian blue. It is also known as Berlin blue. Okay, Prussian blue or Berlin blue. It is of blue color. It is having a blue color pigment, and when it is dissolved in solutions it gives blue color. So this is Prussian blue colloid. Okay, next question. Okay, which of the following anions is the strongest base? We need to say which is the strongest base. Okay, let's form their acids. Okay, let's form their acids first. Any acid will give H plus ion and then its base will be formed. So by adding H plus ions in each one of them, we will get their acids. Okay, so let's form their acids. Here we are adding H plus ion, so it will be HClO. This one would be, by adding H plus ion, HClO2. Now this one, HClO3, and this one would be HClO4. Now let's see their oxidation state of central atom. That is chlorine. Okay. In all these molecules, these are oxy acids. The central atom is chlorine. Okay. So let's see its oxidation state. So here it is +1. Okay. Here, because it's +1 and this is -2. So overall its oxidation state is +1. Similarly over here +3, as this is +1 and this would be -4. Again here +1 and this would be -6. So its oxidation state is +5. Again here +1, here -8, and its oxidation state will be +7. Okay. Now in case of, so their oxidation state of chlorine +1, +3, +5 and +7. Now in case of the oxy acid, as the oxidation state increases, their acidic nature or their acidity increases. Their acid nature increases. So this is the strongest acid. HClO4 is the strongest acid. Okay. This one is the strongest acid. Now we know that if this is the strong acid, then its base would be the weakest. Okay, this one would be the weakest. And now similarly, this one is the weakest acid. Now as this is the weakest acid, its base would be the strongest base. So correct answer would be what? ClO negative. That would be the strongest base among the four. See, as the oxidation number is increasing of the central atom, it requires more and more electrons, okay, to satisfy its octet. Right here +7 oxidation state, it is hungry for electrons. That's why it is very strong acid. It wants to give H plus away so that it will keep both the electrons, right? That's why. So this is the concept. Strongest acid has weak base and weakest acid has strongest conjugate base. Okay. So clear? This would be our strongest base. Clear? Okay. Next question. Okay. Now, okay, let's read it first. The pH of 10 raised to power -9 molar solution of HCl is. Now, look, how do we calculate pH value in normal regular basis? That pH is equals to negative log of H plus ion, right? And what would it do? That from here 10 minus 9 molar, already the value is given. So, right, in normal circumstances we do like this, and then if we would solve it, the answer would come out to be 9, which is absolutely wrong. Just imagine HCl is an acid. Can it have a pH value of 9? Is it possible for an acid to have a pH value of 9? No, pH value for acids is below 7. So never make this mistake. Look over here. It is HCl. It can never have this value. Now, how we would solve it? Let's see. See, when we are talking about HCl, it will completely dissociate, right? It's a very strong acid. So in water, it will give H plus and Cl negative ion. Now, its molarity is 10 raised to power minus moles. What does it simply means? That 10 raised to power minus 9 moles are present in 1 liter of solution, right? So 10 raised to power minus 9 moles of HCl will prepare 10 raised to power minus 9 moles of H plus and 10 raised to power minus 9 moles of Cl negative. Now, as in this case, the hydrogen ion concentration of HCl is very low. Here we will also have to consider the hydrogen ion concentration of water. Okay, so let's write the equation for water also. I am writing over here. Okay, water, it will dissociate to give H plus and OH negative ions. Now in case of water, the values for both H plus and OH negative is 10 raised to power minus 7. Now we will put our values, that pH is equals to minus log of H plus hydrogen ion concentration. Now here hydrogen ion concentration would be this one also and this one also. Okay, so let me solve over here. So total H plus ion concentration would be 10 raised to power minus 9 plus 10 raised to power minus 7. From here I can take 10 raised to power minus 7 as common. Now here 1 plus 10 raised to power minus 2. Okay, and then I can write it like this. 10 raised to power minus 2 is what? 0.01. So here 1.01. Okay, this is my H plus concentration, total H plus concentration. Now we will put this value over here. pH is equals to negative log of 10 raised to power minus 7 into 1.01. Now we will solve it. pH is equals to minus this of 10 raised to power minus 7 and then plus minus log of 1.01. Okay, so now this value would come out to be minus 7 ahead and it would here the negative sign and log to the base 10 and minus log of 1.01. From here when we would solve it, we would get 7 minus log 1.01. So the pH value is somewhat lesser than 7. It is between 6 and 7. So our correct option would be, okay, the fourth option. Okay, note it down properly, nicely. Now, so our correct option would be this one, between 6 and 7, as it was less than 7. Okay, it was what? 7 minus log of 1.01. So it will definitely have some value. So our pH value would be less than 7 and somewhere between 6 and 7. Okay, so but always keep this thing in mind that an acid can never have a pH value of more than 7. Okay, good. Next question. Very easy. Which one of the following is a renewable energy resource? So we all know that petroleum, coal, natural gas, they will all get exhausted if we will overuse them. Windmill is a what? Renewable energy source. Renewable means that can be renewed very easily, which will not get exhausted by human consumption, right? What does renewable mean? Which energy sources which will not get exhausted or finished. Okay, which will not get exhausted or finished by human use. Now if we will use petrol, it will get exhausted. Coal, it will also get exhausted. Natural gas, it will also get exhausted. But windmills, it will not get exhausted. So it is a renewable energy source. Clear? Okay. Next question. Well, which of the following gas is responsible for the depletion of ozone layer in the atmosphere? We know that the gases which are responsible, see all the options. Here, all the options are regarding chlorofluorocarbons, okay? This is our correct option because this is what? Chlorofluorocarbons. Okay, this comes under the category of chlorofluorocarbons. This one is known as difluoromethane, and it is a chlorofluorocarbon gas. Initially, it was being used in refrigerators, in sprays, aerosols as sprays, propellants. It was being used. Now it is banned because it is causing ozone layer depletion. So our correct option is difluoromethane, which is a chlorofluorocarbon. Okay, so this one is responsible. The remaining ones are not. Clear? From all the options, chlorofluorocarbons are responsible for what? Ozone layer depletion. Okay. Next question. The exhausted permutate is regenerated by percolating through it a solution of. Now, exhausted permutate. What is permutate first of all? So, permutate is a artificial zeolite. Okay? Artificial zeolite which is used for softening of hard water. Usually it is mentioned like this. Okay, it is having sodium ions and then that Z is zeolite. Okay, so it is used, artificial zeolite, we use it for the softening of hard water. Softening of hard water. Now we know that the hardness of water is due to, why water is hard? So the hardness of water is due to salts of calcium and magnesium ions. Okay, calcium and magnesium ions like calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. So the hardness of water is due to these ions. Now what happens? We take a bath of zeolite, okay, or permutate, and then the hard water we make it run through that zeolite. Now from this zeolite, the sodium ions exchange themselves with calcium and magnesium ions. Okay, these are also cation, that is also a cation. So they get exchanged. So all the calcium and magnesium ions get trapped in the permutate, and water is now having what? Sodium ions. So the water becomes soft. Now there would come a point when that zeolite will get saturated. There would be so many calcium and magnesium ions. Now we need to regenerate it. Okay, that is what asked in the question, that how would we regenerate it? So we regenerate it by passing a concentrated solution of brine. We regenerate it by passing a concentrated solution of brine, and that brine is nothing but again sodium chloride, NaCl. Now what would happen? These sodium ions will again get exchanged with magnesium and calcium ions on the zeolite. Okay, now again there will be sodium ions in our zeolite. Again sodium ions in zeolite or permutate. Now again it will be useful in softening of hard water, and this is how it would be reused again. So the correct option would be this one, sodium chloride. Okay, concentrated solution of brine or NaCl, that is sodium chloride. So we regenerate it by this. Okay, clear? Very good. Next question. Okay, during reverse osmosis. During reverse osmosis, what happens? Now what is reverse osmosis? What is reverse osmosis? Okay, it is opposite of osmosis. What is osmosis? Osmosis is a process. Okay, first of all, let us understand osmosis. Osmosis is a process in which a pure solvent, okay, it moves from a region of high concentration to low concentration of solvent through semi-permeable membrane. Okay, that is osmosis. When pure solvent, okay, pure solvent will move from a region of higher concentration of solvent to a region of lower concentration of solvent and through a semi-permeable membrane. That is simple osmosis. Okay. Now reverse osmosis, as the name suggests, reverse means now the movement would be that of solvent, but it would move from a region of low concentration to a region of high concentration of solvent. Why we are doing reverse osmosis? It is one of the methods for the purification of water. Water is having impurities. Now we want that the water that is pure to move it from the impurities, okay, to separate it from the impurities. So in this case, what would we do? See, just imagine this is a semi-permeable membrane. Okay, there is pure water. There is water but with impurity. Okay, now here water with impurities or hard water, right? Water with impurity. Now what would we do? We will apply a pressure over here. Okay, we would apply a pressure, an external pressure, which would be greater than the osmotic pressure. Okay, which would, osmotic pressure is denoted by pi. We will apply a pressure over here and that pressure would be greater than osmotic pressure. Now what would happen? We are forcing, we are pushing the water to flow from a region of low concentration of solvent to a region of higher concentration of solvent. Now the impurities won't be able to cross the semi-permeable membrane. Only the water molecules will move from a region of low concentration to a high concentration. It is reverse osmosis. Now our correct option, let's see. Our correct option, dissolved salts are pushed out, no. Only dissolved ionic salts are pushed out, no. Pure water is pushed out. This is our correct option, that what we are pushing, pure water is pushed out through semi-permeable membrane. As I explained right now, that the pure water is pushed, okay, not the impurity. So our correct option would be 3. In the fourth option, it is said that both water and dissolved salts are pushed out. No. Then what would be the sense of reverse osmosis? Oh, to make more dirty water or impure water. So no. Okay. Clear? Okay. Next question. This is theoretical questions, but the concept should be clear. Whether it is theory, it is numericals, the concepts should be as clear as possible. Okay. Next question. Which of the following is a weak electrolyte? What is a strong electrolyte and what is a weak electrolyte? Well, a strong electrolyte is one which gets totally dissociated in water, right? In aqueous solutions, it will get total dissociation. On the other hand, a weak electrolyte will not get totally dissociated, right? So let's see all the options. The first option is HCl. It is a very strong electrolyte. HCl gets totally dissociated like in water. If we talk about aqueous, it will give us H plus ions plus Cl negative. Okay, it will be totally dissociated. It is a very strong electrolyte. Then next, NaOH. It is also a very strong electrolyte. It will also get fully dissociated like this in constituting ions. Okay, it will be fully dissociated. Then our third option is acetic acid, CH3. Now, this is a weak electrolyte. It gets partially dissociated and it maintains an equilibrium with its dissociated ions like this. Okay, so this one is a weak electrolyte. So our correct option would be this option number 3. Let's see our fourth option also, that is H2SO4. H2SO4 is again a very strong electrolyte. Okay, it will get fully dissociated like this in constituting ions. Okay, this is AQ for aqueous. Okay, this also gets fully dissociated. So the correct option is acetic acid, CH3COOH. That is our correct option. Sulfuric acid and these all are strong electrolytes. Clear? Okay. Next question. Okay. When 2 amperes of current is passed through copper sulfate solution for 10 minutes, the amount of copper deposited is, and the atomic weight of copper is given, that is 63.5 grams. Now this question is based on Faraday's first law of electrolysis. What does that law say? That mass deposited is equals to ZIT, that is electrochemical equivalent, that is current, that is for the time for which it is flowing. So now mass we need to find out. Now here we are not having the value of Z. Z is also given as E upon F. What is E and what is F? E is the equivalent weight. Of what? Equivalent weight of the substance about which we are talking about to get decomposed, right? Deposit, about which we are talking about to get deposited. So here we are talking about what? Copper. Okay, so equivalent weight of copper. Now equivalent weight is equals to molecular mass upon oxidation state or valency. Okay, anything. There are different definitions for equivalent weight. That depends about what we are talking. So here, from here, molecular mass of copper is 63.5 gram, and here CuSO4. So here copper sulfate, it is in the form of Cu plus 2. Okay, and sulfate SO4 minus 2. So what is its oxidation state? Plus 2. So here we would write this plus 2. The F's value is, we know that it is 96500. Okay, that is Faraday's value. Now here we will just put all the values. In place of Z we will put E upon F, here I, and here T. Now E is equals to what? This 63.5 upon 2. F, in place of F we would put 96500. Okay, that's all the value. In place of the current, how much amperes? 2 amperes of current. Okay, so we would put 2, and the time it is given for 10 minutes. We always need to convert minutes into seconds or hours into seconds. The time would always be put in seconds. Okay, so 10 minutes and into 60, so it is 60 seconds. Okay, now just we would have to solve it. When we would solve it, our answer would come out to be 0.394 grams. Okay, don't trust me every time. Okay, just solve by yourself once. I might be wrong, but I am not wrong, but it's still solve, and do not use calculators as it might not be allowed in examination halls. Okay, so solve it by yourself. Okay, so very simple. Okay, clear? Everything is clear? Okay, let's move to the next question. Composition of nichrome alloy is, well, nichrome alloy is an alloy of nickel and chromium and iron. Mostly nickel and chromium are present. So here nickel and copper, so it is a wrong option. Yes, nickel, chromium and little bit of iron. So this is a correct option. Okay, so nichrome alloy is made up of nickel, that is 78%, chromium, that is 20%, and iron, a little bit of iron, that is just 2%. Clear? Okay, this you should remember and learn also. Okay, these things are also important. Okay, next question. In the fruit flotation method, pine oil. See, we use these methods for concentrating, our ores, minerals. For that we use it. The principle of fruit flotation method is what? Then some minerals are hydrophobic, some are hydrophilic, and on the basis of that we separate minerals. The function when we add pine oil in the liquid, oil itself is hydrophobic. So as it is hydrophobic, it will decrease the surface tension of the liquid, and as it would decrease the surface tension of the liquid, it will help in the formation of air bubbles. Okay, and then the hydrophobic mineral will get attached to the air bubbles this way. So let's see what is our correct option. No, it does not increase the surface tension of the solution, doesn't act as a collector, does not affect. Wrong. Yes, it decreases the, what does it do? It decreases the surface tension of the solution and helps in the formation of what? Air bubbles. And as air bubbles will form, the hydrophobic mineral will get attached to it. Okay, clear? Very good. Next question. Okay, let's move to the next question. During electrochemical corrosion in acidic environment. Now, let's understand electrochemical corrosion. Corrosion, mainly whenever we talk about corrosion, we talk about iron, rusting. Okay, so see what happens in electrochemical corrosion. Let's say this is an iron metal. Okay, this is an iron metal. Now, inside this one iron metal only, some part of it will act as an anode. Okay, and some part of it will act as a cathode. Now here at anode, always at anode oxidation takes place. So here iron will lose electrons, right? It will get converted into Fe+2 and electrons. Now these electrons, we know that electrons flow from anode to cathode. So here these electrons will come. Now these electrons from here will go in the atmosphere. In the atmosphere, it is acidic environment. Acidic environment simply means here there is more H+ ions, H+ concentration. Now these H+ ions in the atmosphere will take up these electrons. Will take up the electrons and hydrogen gas would be produced. So what? Yes, the option number 1 is the correct option. Hydrogen evolution take place, and here our overall hydrogen gas will evolve and our metal will get corroded. Corrosion will occur. Okay, corrosion will occur and hydrogen gas would be liberated. Clear? Okay. Next question. The process of coating of iron with zinc metal is known as galvanization or galvanizing. So the correct option is galvanizing. Do not get confused with periodizing. Okay, do not get confused between these two terms. Here simply we take iron, we dip iron metal in what? Zinc solution. That's it. So that is simple coating of iron with zinc metal. Okay, that is galvanizing. It is a high temperature process in which there would be reactions of iron with zinc powder. So that's a different thing. This is a high temperature process. Okay, this one is a high temperature process, and here iron will react with zinc powder and then there will be a coating of zinc over iron. But here simply iron metal is dipped into zinc. That's it. Okay, so do not get confused between this and this. Clear? So our correct option would be galvanizing. Okay. Next question. Bakelite is prepared by condensation polymerization of. Bakelite is prepared by phenol, condensation polymerization of phenol, and excess of acetic acid, sorry, formaldehyde, phenol and excess of formaldehyde in a basic solution. Okay, so this phenol and excess of formaldehyde. So yeah, our first option is correct, that phenol and formaldehyde. Phenol and excess of formaldehyde, first of all they will form an intermediate. Okay, first of all an intermediate would be formed. This intermediate would be formed. This is what? Intermediate, and its name is ortho and para hydroxy benzyl alcohol. Okay, here ortho and para. Here this group is at ortho, here this group is at para. So ortho and para hydroxy benzyl, this group, this entire group is known as benzyl alcohol. Okay, now n molecules of this and n molecules of this will condense and water molecule would be eliminated and our cross polymer bakelite would be formed. Let me draw that for you like this. Okay. Okay, like this. These were our intermediates. This one is ortho and this one is para hydroxy benzyl alcohol. Now n molecules of this will combine with n molecules of this and water would be eliminated. From where? See, here there is hydrogen, right? So this OH will react with this H and a bond will form and water would be eliminated. So like this. Okay. Then again another chain. Okay. And now from downside, this molecule will react. Like this. And in this way bakelite, cross-linked polymer bakelite would form. Okay, so this is a polymer of what? Phenol and formaldehyde. First an intermediate, that is ortho and para hydroxy benzyl alcohol is formed, and then that they condense together, and with the loss of water this bakelite is formed. This is bakelite, cross-linked polymer bakelite, and it is having what? Cross linkages. Okay, these are cross linkages. Clear? Okay. Okay, next question. The trade name of the polymer coated on the non-stick utensils is, well, on our non-stick utensils, well, this Teflon. Teflon is present. Its name, chemical name is what? Tetrafluoroethylene. Okay, tetrafluoroethylene. This is a polymer of, it is a polymer like this. Here it is fluoro, like so many tetrafluoroethylene units will combine together. Okay, polytetrafluoroethylene. This is also known as polytetrafluoroethylene. So this is used as in non-sticking utensils. Utensils for coating in utensils, as it is resistant to high temperature. Okay, so that's why it is used there. Clear? So Teflon is used over here. Okay, next question. Okay, octane number of a petrol that consists 20 to 80 ratio of anhapten and 2 to 4 trimethyl pentane. Okay, so what is 2 to 4 trimethyl pentane? Is nothing but isooctane. Okay, this is isooctane like pentane. There, like this. Okay, 2, 2, this is 1, this is 2, this is 3, this is 4, this is 5. Okay, this is 2 to 4 trimethyl pentane. This is nothing but what? Isooctane. If you will count all the carbon atoms, so there are in total 8 carbon atoms. This is isooctane. Now the formula for octane number. How do we determine octane number? Is equals to, now fraction of anhapten into octane number of anhapten. Okay, let me rub it. Okay. Okay, fraction of anhapten into octane number of anhapten plus fraction of isooctane into octane number. Here octane number I am writing, octane number is O dot N. Okay, octane number of isooctane. Now in order to determine this octane number of fuels, well, the straight chains, they are having very less octane number. Okay, like anhapten is having octane number of 0, so its fraction is what here? 20% anhapten. Okay, so its fraction is 20 by 100 and its octane number is taken as 0. Now fraction of isooctane, it is 80%. So its fraction is 80 upon 100. Okay, total is 100. 20 plus 80 is 100. So out of 100, 80 parts are of isooctane. Its octane number is taken as 100. Okay, octane number determines that how much a fuel provides resistance to knocking, and if in case of the linear chains of hydrocarbons, they are very prone to knocking. On the other hand, branched chain hydrocarbons, they are very resistant to knocking. Okay, very resistant. So this is having octane number of 100 and anhapten, because it is linear anhapten, like linear chain, its octane number is 0. Now if we would solve it, this term would become 0 here. So our answer would be AD. Okay, clear? Yes, here our answer would be option number 3, AD. Keep this in mind, this is very important. Okay, next question. Well, producer gas is a mixture of carbon monoxide and nitrogen. This is what our producer gas. Okay, a little bit of hydrogen is also present, but in little quantity. In none the option, okay, it is given, so no need to worry. Mainly it is carbon monoxide and nitrogen. So this is our producer gas. It is nothing but a fuel. Okay, these all are what? Fuels. It is used as a fuel and it is a mixture of CO and N2. Clear? Next question. Okay. For the following cell reaction, this is our cell reaction. Okay, this is our cell reaction. The EMF of the cell at 298 Kelvin is when these two values are given. Okay, so what we need to find out? The EMF, standard EMF of the cell. Why standard? Here nowhere is written standard. Well, at 298 Kelvin, this itself means what? Standard EMF, that is E naught, and we know that E net of a cell is equals to E naught cathode, standard electromotive force of cathode minus anode, E naught of anode. Now cathode is where reduction takes place. Now see which of the two atoms is getting reduced. Here its oxidation state is 0, here it is +2. It is getting oxidized. Okay, what is happening over here? Oxidation. And oxidation takes place at anode, right? And here Ni+2 and here its oxidation number is 0. So here reduction. And reduction always takes place at cathode. So first of all, we need to put value of this Ni+2 to Ni, that is here. Okay, so we would put its value over here, that is -250. Now minus that anode is given as like this, -0.440. Now simple, just simply solve it. Okay, nothing else to do. Minus, this would become plus. Now minus plus minus, it's 0, it would be 9, it would be 3.0 and it is bigger number, it's in volt. So our correct option would be 0.390 volt. Now I will have to move the screen. Okay, note down it. Okay, now let's see. Did I make a mistake? Let's see. In calculation, here it was E naught cell is equals to, yes, sorry, calculation error, minus and that is 0.440 minus 0.250. It would be plus 0.440 and 440 is 0, 9 and 1. Yeah, sorry. It would be plus 0.190 volt. So our correct option would be the option number 2. Okay? Clear? Do not make mistakes like me and do not use calculators. Very good. Okay, next question. In hydrogen oxygen fuel cell, the reaction at the cathode is, now hydrogen, oxygen and fuel cell. What is it? Fuel cell. Fuel cell is what? In this cell, fuel is used to produce electrical energy. Okay, fuel. Here in this case, we are using what? Hydrogen, and we are making its combustion. Hydrogen is getting what? Combusted in order to give us energy. Okay. Now, here, one of the electrodes will act as anode. The other one will act as cathode. There are only two electrodes. First one is hydrogen and oxygen. Okay. Now these two will react like this. This is the reaction. Now see, hydrogen, here its oxidation number is 0. Here it is +1. Here it is 0. Here it is -2. Right? Because these are 2, so +1 and +1, 2. So it is overall a neutral molecule. Okay. Do not get confused. So here it is what? Getting oxidized. So it will act as anode, and our oxygen, this one O2, it is getting reduced. So this will act as our cathode. Now we need the reaction at cathode. So at cathode, oxygen in the form of gas would react, will gain electrons. Okay, and it would form water. Okay, it will get reduced. So our correct option would be option number 1, this one. In the remaining option, this is this. So this is not cathode, this is anode. This reaction has no meaning. Okay, so our correct option would be option number 1, where our cathode, at cathode, this would act as our cathode. Okay, clear? Here also in fourth option also hydrogen is taken, but our cathode is oxygen. Hydrogen is anode, it is getting oxidized. Okay. Next question. I think this question you all must be knowing from very small classes. What is smoke? It's a combination of what? Smoke and fog. Smoke from industries and fog from the atmosphere. So it is a combination of smoke plus fog. From the fog, from smoke, from water vapor. No. Let's see. Yes, our fourth option. Smoke is derived from both fog and smoke. Smoke is nothing but the combination of fog and smoke. Clear? Very easy question. Okay, let's move on to the next question. What do BOD and COD stand for? Well, BOD and COD stands for biological oxygen demand and chemical oxygen demand. This are first option. Okay, biological oxygen demand and chemical oxygen demand. What is biological oxygen demand? Well, in water, how much microorganisms require oxygen, or how much amount of oxygen they absorb in order to decompose organic matter. This will tell us about air pollution. It will tell us that are there any pollutants in the water. If they are requiring more oxygen, means there are more organic substances in the water, means there are chances of pollution or some impurities, right? So this is a measure of that. This in case of water, right? And chemical oxygen demand, simply when we see how much amount of oxygen is required to oxidize organic matter, but chemically, in like test tubes and like that. Okay, the full form of BOD and COD is what? Biological oxygen demand and chemical oxygen demand. Clear? These other options now, see, this is opposite. Chemical, it's COD. There, read the question carefully always. Respectively simply means the first one and then second one should be later. Okay, now here the answer is here also correct, but the order is not correct. Okay, with this we are done with our 25 questions. I hope you got all the answers. Okay, study properly. Thank you.